So now that we talked about the utility classes that are part of the ex45 case study, let's talk about the driver class and talk about what the overall behavior of the program is going to be. So we're going to talk about the ex45 class itself, which has a bunch of methods in it, and we'll talk about how those methods work and what we're trying to do with the output that comes out. And I'll actually run the program to see what it does. Again, this class also uses the Java Streams framework very extensively. It doesn't use parallel streams, it uses sequential streams. So one thing we have here is a method that tests our makeRegex utility method, and I'll show you how that works. We basically give it a quote, and we give it some words to match, and we give it a regular expression, and then we see if there's a match. So that's one thing it does. We then also read the complete works of Shakespeare from a text file and store them in a list. You can see how we do that here. We then use a couple of other methods to search for occurrences of a specific word. In this case, the word is Lord. And we're going to filter this list to only include works that contain that word. And then we're going to compile a regular expression pattern for further matching. And we're going to use the makeRegex utility method we just talked about to add to the regular expression true or false. So you can have things that match true or false. Then we're going to take the filtered works, the ones that contain the word Lord in them, and that compiled regular expression pattern, and we're going to find and display all the matching lines for each work, which will look like this. OK, so let's talk about the methods real quick, and then we'll look at the code. So the main method, as always, is the entry point into the program. It reads the complete works of Shakespeare into a list of strings, and then calls some other methods to do its bidding, which are test_regex list and process barred works. We have the test_regex list method, which we see will construct a regular expression and then check to see if something we create as a string matches anything in that regular expression. We have process barred works, which searches the works of Shakespeare for a specific word using regular expression matches. And to do this, it calls the find match and show regex matches methods to display the matching portions. And it might not surprise you that find match is going to go and look for matches in a work of Shakespeare to see if the word Lord, in this case, occurs anywhere. And to do this, we're going to use a very cool Java feature called a BreakIterator. So I'll show you how to use the BreakIterator, and it's kind of cool. And then finally, we are going to take the list that has the works of Shakespeare that matched Lord and the compiled regular expression it's looking for Lord, followed by anything, followed by true or false, followed by anything. And then we're going to go ahead and find anything that matches that. And we're going to collect and print these matches organized by the title of the work. And of course, we're going to use streams everywhere to make everything very fluid and fluent and flexible. So let's go ahead and take a look at how that works. So we're back in the ex45 project, and now we're going to look at the ex45 class. And as you can see here, this is going to have the complete works of Shakespeare file. And if we look over in the resources folder, voila, there it is. And these are all the works of Shakespeare. I'm not going to bore you with going through them, but they're all there. And let's go ahead now and take a look at what the main method does. It starts out by creating a new instance of ex45. I do this, I make a new instance because main is always a static method. So if you want to make method calls that are non-static, then we need to make an instance, which is what we're doing here. So we first test the makeRegex method. We'll look at that. And in fact, let's look at that first, just because we're there. And let's see what it does. So what that's going to do is it's going to take a string quote using the modern Java text block syntax. So text blocks allows you to break strings in clever ways and not have to do all kinds of extra stuff by putting plus signs everywhere. So this says, the quick brown fox jumps, new line, over the lazy dog. And I put a new line in here for deliberate reasons, as we'll see. We then make a list of words to match: cat, dog, mouse, and socks. We then call makeRegex to take that list and make a regular expression string. And then what we're going to do is we're going to take the quote, which is this string up here, and we're going to lowercase that quote. And then we're going to go and see if the lowercase quote string, the quick brown fox jumps over the lazy dog, matches anything in the regular expression string. And so we go ahead and tell it to do that. And the question mark S thing says match across lines, across new lines, which is why we put the new line in the string, so to see if we can match properly. If we get a match, we make result be matches. If we don't get a match, we get result say does not match. We print the result. The quote results, which is either matches or does not match, the regular expression string. So just so we keep continuity here, let's go ahead and run that program, and I'll just show you that piece first. So that's the first thing we see. So it says the quote, "The quick brown fox jumps," new line, "over the lazy dog," matches the regular expression string, and here's our wonderful regular expression string that we created. And the reason it matches, of course, is because it matches dog. So there's a match. OK, so that's the first one. Now, I did that just to show off some interesting things. We're going to use makeRegex later in other parts of this program as well. The next thing we do is we go and we get the list of strings containing the works of Shakespeare, split using the @ sign. And then we're going to call process barred works, passing in the barred works, which are going to be the whole list of the works of Shakespeare, and the word Lord as a string. So let's go take a look at process barred works. This has got some pretty cool stream stuff in it. So what we're going to do first is we're going to go find every work of Shakespeare that has the word Lord in it. And we do that by saying barred works, which is a list of strings, turn that into a stream of strings. Then we use filter to only keep things that match the word in the work. So remember, the word is Lord. And then we come over here and we take a look and see what find match does. Here is find match. Find match is super interesting. This is what uses a BreakIterator. BreakIterator is a Java class that you can use to break text up into chunks. You can break it into characters. You can break it into words. You can break it into lines. You can break it into sentences, and so on and so forth. We're going to break it into words. So we get back a BreakIterator, and then we set the work to be the text that the BreakIterator will break on. And what BreakIterator does is it will just return to you the beginning of each of the words, the beginning and end of each of the words in the text. And so what we do now is we use Java streams with the iterate factor method, which is another factor method that makes a stream. And check out what we're doing. This is really interesting. We are going to say start with the first boundary in the BreakIterator. Keep going until we're done. And every time you're finished, iterate to the next break, next boundary in the word. So that's how you read this. It's kind of like a for loop, but it's a stream, if you will, or like a while loop. And what we do is we then essentially convert this result, which is a stream of boundaries, into a list. So we have a list of integers, which are the boundaries, which is where the words are beginning and ending in that work of Shakespeare. So now we have a list of word boundaries. And now what we're going to do is we're going to use the range method, which is another super cool little functional for loop technique. And we're going to go from range equals 0, because of course everything starts at location 0 in Java and C++ and C# and C. And we're going to go until boundaries.size -1. And you'll see why we do -1 here in a second. So now we're going to have a series of integers that correspond to basically 0 through size -1. And then we're going to map to obj, which means we're going to take these integers and turn them into objects. And what we're going to do is for each integer I, from 0 to size -1, we're going to index into the boundaries list. So we're going to say boundaries.get sub I, which gives you the beginning of a word. And then we're going to have boundaries.get sub I plus 1, which is the end of the word. And we're going to strip out the string or the substring from the work of Shakespeare at that boundary. So what we're doing here is we're basically getting a stream of words. And then for the stream of words, if the AnyMatch terminal operation returns true, we're done. So what this is saying is if the word that we get that goes through here equals the search word, that returns true. AnyMatch returns true. So the first time we find the word, we stop. We don't go any further. This is an example of what's called a short-circuiting operation in Java streams. It's a short-circuiting terminal operation. So what we end up here with, basically, is true or false if the word Lord appears anywhere in the text. And just super really cool, very concise, showing the power of streams, no loops, no if statements. It's all done in a functional way. So that's how process barred works initially. We're going to get ourselves a list of strings that contain the word Lord. And then what we're going to do is we're going to make ourselves a pattern And again, we're going to use stream of because we want to make a stream. And we're going to say, make me a new regular expression that has the word we're looking for, Lord, followed by anything, followed by true or false, followed by anything. So that's the next regular expression we make. So it's Lord as a word, followed by anything, followed by either true or false, followed by anything. So we reuse the makeRegex utility method. And then we take that pattern matcher, we take that string, and we call pattern compile, and we compile this as a regular expression that will be case insensitive, so it'll map uppercase and lowercase strings the same. And then we return that pattern. So now we have a pattern that comes back with find first or else. And at this point, we then call show regex matches. And this is another super cool method. This takes the list of Shakespeare works that matched Lord and the pattern we just made, and it's going to do some really cool things. And I'll tell you a bit about how I came up with this implementation in a second, but it's really interesting. So we take all the things that match Lord, turn it into a stream. So we have a stream of strings. And now we're going to use the map method to create a different data structure altogether. So we have a stream of strings, which are the contents of Shakespeare. And now we're going to map it into something called a simple entry. So you can see we have a stream of simple entries that come out of this. And the simple entry is just essentially a very simple data structure that has a key and a value that are generic. The key is going to be a string, which is the title of the work. So we get the first line out of the work, so now we have the key being the title. And the value of the simple entry is going to be the result of calling pattern matcher on the work, which we'll find everywhere where the word Lord is followed by true or false. And there could be multiple places where that occurs. So that comes back as a results stream. We turn that into a list. So we end up with a list of all the things that happen to match that. So what we now have is coming out of map, we have a new simple entry that has the title of the work and either a list with something in it if there was a match or a list with nothing in it if there was no match. And then we go ahead and we filter out anything that didn't have a match. So if the value of the entry is empty, there was no match. So we just get rid of it. So you have to have things that are non-empty. So now what we do is we take the stream of non-empty simple entries that matched, and we collect them into a map where the key in the map will be the work of Shakespeare, that's the key, and the value will be the list of matches that occurred. So we now have a map that is a map of titles followed by matches. So now what we're going to do is we're going to print some little helper diagnostics. The number of works that match is the size of this map out of a total of the size of the total number of entries. And then we're going to say the matches for each work are the following. And what we do is we take that map and we iterate through the map. And for each key value pair in the map, we print the title. And then we take each of the values and we print out the matches, indicating where they happen to, what the match was, and where they started as an offset in that work of Shakespeare. So if we go back and take a look at the results of running this thing, you can see that the number of works that match was 13 out of a total of 37, and the matches for each work are, and then it lists all the matches for each work. So first the title goes, so like The Tragedy of Hamlet, Prince of Denmark. Lord, 'tis true is what matched, and that's the character where it matched. That's the offset where it occurred in the file or in the string. You know, again, just different quotes. We could have searched for other things. Lord of more true gentleness. That's a nice match because you can see Lord was in there, true was in there. Lord was in there followed by anything, followed by true, followed by anything. So that's a nice example of using regular expressions to do the matches. OK, so that is basically how that program works.